examples of network intrusions. So basically this lecture is about intrusion detection and prevention. Okay, so it's composed of three parts. The intrusion themselves. So we saw examples of network intrusion last time. We will I will show how these intrusions are implemented. Then intrusion detection, how to detect intrusions, techniques of detecting intrusions, and the last part will be intrusion prevention. Okay, so we saw one part. We will do some examples today. We saw, for example, DNS kind of poisoning. A lot of types of poisoning of DNS, like DNS cache poison, DNS file poisoning, or local DNS poisoning, then DNS cache poisoning, and sending extra DNS records, and then ARP poisoning or ARP sniffing. Okay. Yeah. So before we go to intrusion detection, last time we saw. I showed you how denial of service, simple attack of denial of service. Today we will see two other attacks, which are ARP poisoning or ARP cache poisoning and DNS poisoning. Okay, so here what we have. Okay, so we have this machine, we have this machine, and we have this machine. So basically we have three hosts here. So I'll show you the topology. Basically we have one Kali machine, which is the attacker's machine. Okay. Then we have Windows XP SP3 SP2, which is the victim basically. And then we have router. So basically it is at the same time a router and gateway. So router and gateway. So basically this router, it has two network interfaces. It has the local area network, so LAN, and then it has the wide area network, which is internet basically. Okay. Okay. So here, Kali will try to attack Windows XP SP3 using this ARP poison. So basically, the goal of Kali is to see all the traffic that Windows XP is sending. Okay. So basically, Windows XP SP2 here, when it opens a browser and it tries to browse the internet, it will communicate only with the gateway, right? And all the traffic basically will be back and forth of the gateway. Now, all the traffic normally Kali cannot see it, because Kali also communicate with the gateway only that. Now, Kali will try to carry out a man-in-the-middle attack. It will try to place itself between the router and the victim. Okay, and it will have access to all the data exchange. So this can be done with ARP poisoning. So the idea here, when Windows XP wants to get the address of the router, basically to connect to internet, it will use ARP. So basically, when it uses ARP, it will do what exactly? So basically, it has the IP of the gateway. It is somewhere in the configuration, okay? And it will try to get its MAC address, because in order to communicate, you need the IP and the MAC. So it will broadcast a message. This is how ARP works. We saw it last time. It will broadcast a message to everybody, telling who has this IP. Okay, who has this IP? Normally, only the router will respond because it's its own IP. All the others, normally they should discard that message. Okay. So here the point is that Kali, since it needs to place itself between the router and the victim, it will claim that it has that IP, right? So basically, it will answer. And not only it will answer, it will flood the victim with wrong mappings, okay? With wrong mappings. Okay. And At the end, Windows XP will believe that Kali is a gateway. So it will believe that Kali is a, yes.
So Kali should be in the network before Windows XP?
Not really.
So
Not really.
Because it's
no.
the IP.
No. Here I am describing a typical scenario, but what happens really is that at any time, for Kali to change the ARP mapping, it will just start floating. It will not wait for the broadcast message. It will float Windows XP with wrong mappings, so that it will force Windows XP to change its mapping. You see? Okay. So at any time, if Kali wants to launch the attack, it will just float because ARP protocol it will keep a cache. I think for Windows Windows machines, the ARP cache is kept for 5 minutes. For Linux, I think it's 2 minutes. Okay. After those 5 minutes, it will try to refresh the ARP cache. Okay. So here again, Kali will not wait for that. It will float. It will force Windows XP to refresh that. Yes.
So the flood is the same MAC address or different? Same one
No.
map?
No, here the float are packets sent to Windows XP containing two information. Basically, the MAC address of this of the IP you are looking for is mine, and it is the phone. So it will give its own IP MAC address.
And it will flood the same packet?
The same packet, yeah. It will repeat it. Okay. So this is exactly what we will do here. So there are several tools for ARP poisoning. Of course, ARP poisoning is a local attack, so you can carry it out only on a local area network. Okay. The tool we're gonna use is called EtherCap. So to launch it, EtherCap. Okay, so this is the tool. First of all, let's get the IP of this. So the IP is 192.168.1.100. This is the Kali IP. Now the IP of Windows. It is 102. Okay, it is 102. Okay. Now here, when we have EtherCap, so we will try to launch NARP poisoning. So basically, we will start the type of sniffing. It will be unified sniffing. The interface ETH0. Then, first thing to do is to scan for the hosts in the network. Okay. So here, scan for hosts. It will scan. It says here 2 hosts added to the hosts list. So there are 2 hosts. What are those 2 hosts for you? The gateway and the Windows XP. Okay. So basically here hosts list, and this is the host list. So you have 101, this is the gateway, and 102, this is the Windows XP. Okay. Now to launch a man in the middle attack using EtherCap is a man in the middle attack tool. And if you go to man in the middle here, you have ARP poisoning, ICM period. There's several techniques for doing that. But the most common is the first one, ARP poisoning. Okay. So we click on ARP poisoning, sniff remote connections, and then okay. And then, so the attack did not start yet. Okay. So here basically, to launch it, you go to start sniffing.
Have a specified target?
Oh yeah. You're right. Stop sniffing. Yeah, I did not pick the target. Okay, so basically we need to specify what are the targets of the ARP poison, who will be floated, etc. So basically it's a man in the middle, so you need to specify 2 targets, so that you will place yourself between them. Okay,
Does it follow the traffic to the port from?
Yeah, if you
because
launch the attack,
you want him to think that he's connected to the.
Yeah, this is the point. Yeah, I forgot to finish this. Basically, Kali will float the XPSP2 with wrong mapping, but also this will force all the traffic in this direction, basically. So all the traffic in this direction will be this way. So if the Windows XP want to send something to the gateway, it will send it first to Kali, and then Kali will forward. Now you need to do, for the opposite direction, you need to do the same thing with the gateway. So you float, the gateway will say, who has the IP of this machine, okay? Kali will do the same thing, will say, I do, and this is my MAC address. So that the router will think that Kali is the Windows XP, okay? And basically all the traffic in this direction will go through the attacker's machine. Okay, so in both directions, of course. Yeah. So here, first one, add target 1. So, and the second one, add target 2. Okay, we are done. So now, ARP poisoning, sniff, and then start sniff. Okay, so start unified sniffing. Now, to just check what is going on, you go to the Windows XP, and then if we type ARP-A, it didn't. Yeah, this is
Still the same.
still this. No, normally. Okay.
Clear the cache first.
Huh?
Try to clear the cache.
No,
Yeah, okay.
no. Plugins. Plugins, and then check poison. This check if the poisoning is going on. Okay, so just plug in. So just will check it.
It's a different network. It's not a So, in the end, the IP will not be the IP of the original gateway, right? It will not
It will
be.
be the same IP. Different.
Yeah. So basically, here, if we display the cache in
reality config gateway features.
yeah, now it works. Yeah. Okay. See. So basically, from the point of view of the victim, the gateway and the Kali have the same mark.
Yep.
Okay. So basically, Kali successfully convinced Windows XP that it is the gateway. Okay. Now with this, you can have access to all the traffic. So here we're gonna you can if the victim visits a website, you will be able to see it from Kali. Okay. So for example here. View profiles. So let's say here from Windows Windows XP we open a browser. There's no. Okay, 24. So here, I think I need to log in. Google, for example. Okay. I think it goes through the Zscaler and stuff. Profile. You see. So basically, everything you write.
Sure.
So see, this is from the Kali. And it is watching out everything that Windows XP is doing. So I tried google.com, it is there. This is Zscaler by the
Zscaler.
yeah, the ITC stuff. So basically, it's washing out everything the victim is trying to do. Yes.
Can I use Wireshark to set other architecture?
Yeah, you can now in Kali, if you open Wireshark, okay, Wireshark. You can watch everything that the victim is doing.
To select something space.
Okay. Okay, so it's watching. So basically here, if we go back there and then we do, let's say here, anything else, Yahoo for example. You see all that corresponding traffic. Okay, so you see everything basically, because all the traffic will go through the attack. Now, this is a passive attack. If you remember, there are passive and active. This is a passive man in the middle, where the attacker can just watch the traffic. It doesn't change anything.
That's all you're trying.
Yeah. So now you can use the same tool to carry out an active man in the middle, where the Kali here it will try to modify the packets going through it. Okay. So for that we use what? We use what we call filters. Okay. So the filters, this is basically a small program running here that will filter the packets. Filter them meaning what? If you can do it with the signatures. So you specify, if you find this information in the packet, I don't know, block it or change it or replace it or whatever. And there is a full language for that, syntax. Okay, so here. User share. So, for example, if we open here, there are several, but yeah, examples. Okay, filter, examples. Okay. So these are small examples of what we can do with filters. Okay. So it's a specific language to specify the filters. And then you specify you write your filter and then you load it with the ethercap as part of the method. So here, for example, this small filter, it does what? It's intuitive. You read it, you understand what it does. What it does.
It's a switch protocols. Traffic.
So basically here, if the protocol is TCP, and if the source IP source port is 22, which corresponds to SSH, or the TCP destination is SSH. So if the packet is coming or going to some SSH port, you log it. You print the message. Okay. So it will basically log everything related to it. This is still passive. Still passive. And this one. Yeah, this one, it does one. So here, if protocol equals TCP and the source is, so if it is going or coming from 23, which is telnet, what you do, you log the data. So data here is the payload of the packet. This is the payload. What you do, you execute a certain prop. So if you see anything telnet, you execute a certain prop. Okay. So you can do plenty of other stuff, like here what? What it does here. This is more specific now.
Change the payload.
Here you will change the payload basically. If data, this is the payload, and plus 20, it means what?
What's the head?
So at an offset of 20 bytes, starting from the beginning of the payload, if you find these two, 41, 42, this is AD basically, okay? You replace that, so basically if data, data here, you replace that same 2 bytes by 42, 43. BC. Very simple example. So at particular position in the payload, if you find something, replace it with something else. Else, with data modified, what is this doing here? Here it uses certain function, search. So basically you are going to the payload and you are looking for this string, search the payload for this string, ethercap. If you find ethercap, what you do? You print this message and then drop what? Drop the packet, okay, and kill the connection. Yeah, stop the connection. So basically, this is This is a sensor. This is censorship, basically. Okay, you find
Detection.
Huh?
Detection for the intrusion.
Yeah, but not even. This is prevention. This is because it's blocking. But this is how sensors work. If you see some keyword like politics or terrorism or something, you kill the connection. Okay. So you have other lot of things you can do with EtherCap. All these are examples of active, basically man in the middle. Okay. So once you so for example here, let's open ether.kfupm. Okay. So then ether. No, KFUPM. KFUPM. No, this one. Ether. KFUPM. Yeah. So what this will do?
Protocol is TCP.
If the protocol is TCP and you search data, you find KSU, Saudi University. Okay, what you do?
Place.
You log it and then you replace it with KFUPM. Okay. So yeah, it's very simple. Let's try this. But here the problem is I need to be connected to internet. It seems I am not.
You try a different browser.
No, but it's not.
You are connected to a router, right?
Huh?
Router. You are connected. Both.
Yeah, through the router. But the router just forward the traffic. Here. Okay, let me check this. .com. It's not right. For some reason it's not right. Anyway, so basically what you do here to launch this filter or to enable that filter, you go to filters here and load the filter, and then you pick the filter you just did, the KFUPM filter, and then okay. So basically it says here content filter is loaded. So this filter will be loaded now. So for all the traffic that the victim is doing, if you see any KSU string, it will be replaced by KFUPM. Of course, if you are going to Google, for example, you went to Google and you are trying this, would it work?
No, it's encrypted.
Yes. So now, if you are doing it with Google, it will not work because Google is encrypted now. All the traffic, all the data inside the exchange is encrypted, and man in the middle in this way, it will not work if the traffic is encrypted. But if you try it with Bing.com is not encrypted.
It has two versions.
It has two versions, but by default it's not encrypted. You write Bing.com, it will go to the encrypted version and it will work. Okay. Yeah. Now, last thing, let's check the DNS Poison. So let's close this. And for here, I need to launch another VM, which is I need to launch USB. Okay, let's launch it. And DNS, it is etc intercap, so ed etc intercap. Okay, so here it is a part of EtherCap, so ether.dns. This is also a feature of EtherCap that will allow you to do DNS Poison. Okay, so what you do, you go to this file in the configuration of EtherCap and you specify the mapping you want. So for example, if it is if the victim asks for gmail.com or the IP of gmail.com, you'll provide this one. Okay. So if it asks for all this, you'll provide the. So here we will basically I have another machine which is Windows XP SP3, this one, and we will try to redirect the traffic to, for example, gmail.com to this machine. Okay, so let's see the IP. Yeah, so 192.168.1.101, so it is fine here. Okay, so here, if the victim tries gmail.com, it will redirect them to this one. Okay, so here, let us open Ethercup again. Okay, then sniff, unified sniffing, okay, then hosts, scan for hosts, 3 hosts now hosts lists, and then you will, this is target 1 and 102 is target 2, so 101 is also the attackers, so I'm in the middle of poisoning, and then start.
But 102 is SV2.
Yes, yeah. It's the same. I will repeat the same thing, but now I will do DNS poison. Okay. SP3 is the attackers, is controlled by the attacker. Okay. Now manage the plugins, and all what I need to do now is DNS spoof. So send spoofed DNS replies. Okay. So here, activating DNS spoofing plugin. Now, if I go to the victim, which is here, and I go here and I type gmail.com. So gmail.com. Okay. So it goes to, this is a server which is installed on Windows XP SP3. Okay. So, and the point here, the victim, when you see the URL, it is a true one, it's correct. It's not the Gmail1 or Gmail or something. It is gmail.com. But since we played with the DNS, it will be redirected to this is the attacker. So here, the attacker, what he can do here?
Say, for example, welcome to the new gmail.com
Not
site.
even new. He can just set up very similar
Yes.
interface. And this is called what? What's it called?
Phishing.
Phishing. This is phishing. Phishing. Here, you specify the same interface as Gmail. It would work. Okay.
But in modern websites, they use certificates in the browsers.
But see, the certificates, that's not a story. I showed you how this can be done if the traffic is not encrypted. But even if it is encrypted, you can use fake certificates. So if the user is not security aware, he will, when he will be faced with, would you like, this certificate is not genuine, would you like to accept it, to go to gmail.com? Yes, of course, I want to go to Gmail. Okay. And yeah, if you accept fake certificates, alas, even if the data or the communication is encrypted, it will go. And I can show you how this can be done with Ethercup. Okay. So basically here, the attack, basically, since there is ARP poisoning and Windows XP is trying to access a server, Gmail, for example, which is encrypted. Okay, so all the traffic should be encrypted, right? Yes. Now, Kali, it might do man in the middle using fake certificates like we did with Diffie-Hellman. This is the same idea. It will do with phone. It will open a secure connection with Kali, okay, with one certificate, which is a fake one. Okay, then it will open a true connection with the Gmail, which is valid with valid certificates. Now, if Windows XP, when it is exposed with the message saying, would you like to accept this certificate? And it agrees, the communication is encrypted, but it is basically controlled by here. Okay, basically, Kali is opening 2 secure connections, but all the traffic is encrypted. Okay. Yeah, so this is it now for this part. Let me go back to the slides. Now, intrusion detection now. How all this can be detected on network types of attacks. There will be inevitably security failures, and there is a need to detect intrusions in order to block after. So yeah, detection should be implemented. Okay, so if you have a network, you need to have a mechanism to detect intrusion. For example, if you suspect that there will be an ARP poisoning. ARP poisoning, it is based on the fact that the attacker will flood the victim with a lot of packets at the same time. ARP, fake ARP mappings. Okay, so you can have a kind of pattern, a model for such attack, and you can detect it. Okay, because if you watch out all the traffic or all the network, you can see abnormal behavior here and there. Okay, so why detection is important? Because if you can detect attacks very quickly, you can even block them. If you can detect them at the right time before they proceed, okay, in the middle, you can block them. Okay, act as a deterrent. If an attacker knows that there is some detection mechanism, he will think twice before launching the attack. And collect the information to improve security. Of course, even if the attack is successful, for the future, if you have details about what happens, you can protect against future attacks. So intrusion detection assumes intruder will behave differently. This is the major detail that will allow attackers that allow to identify or detect intrusion, which is the intruder will behave in a different way than a normal user. Okay, so for that, this is profile of a normal user, authorized user. So you have a certain profile. Here, when I have this curve, it might mean several things. It might mean numbers, it might mean statistics, it might mean time, several things. Okay. Now, and this is the behavior of an intruder. Okay. So you see, they are quite different. So basically, the behavior of the intruder deviates from the normal one. Okay. But the problem is this one. So this will allow us to identify, detect, most of the time. Okay. But the problem is this overlapping. What does it mean overlapping here?
Similar activities.
Similar activities. So basically, you have an event that might be interpreted as normal or abnormal. Okay. You name it, several issues. Now, this will cause what we call false positives. Okay, false positives or the opposite. True negatives. Now, false positives means what? It means you detect something. It looks to you that it is an abnormal behavior, but actually it is a normal behavior. So basically, you are blocking valid traffic. Okay. And all this happens in the overlapping part.
But if this area is very small, it's okay. Right?
It's okay. Yes, it's okay. We cannot remove completely the false positives. There will be always this, and you can. It's a trade-off, basically. It's a perfect situation would be to have a false positive 0, but it is difficult to achieve. Now there are two types of intrusion detection. There is statistical anomaly detection and rule-based detection. Okay. Now here there are a lot of descriptions, but to summarize, okay, what is saying this slide. In order to detect intrusions, you can do it in two different ways. Either to have a signature or a model for attacks. Okay, you know that there might be 10 different attacks. Okay, you have a model for each one of them, and while the communications are going on in your network, you will try to match. You will try to see if those model exists in the network. Now, the signatures you have are signature for attacks, okay, for abnormal behavior, for intrusion behavior. Okay, this is the first one. The second one is you will maintain basically signature or model of normal behavior. Okay, the signatures you have, this is for normal behavior, and as soon as you see that in the network there is something that deviates from that normal behavior, you will alert or you will raise a flag or whatever.
So most of the IDS use the first one.
The first one, yes, the first one. So they have signatures for malicious behavior.
The second one is more secure.
It depends, because here in the first slide we saw that the intruders, there are two types. You have the misfeasor, not misfeasor. The first one is masquerader. Masquerader is an external attack. It's not part of the system. Does not have an account or whatever. Okay, and the misfeasor, which is an insider, someone who has a user account, but he is trying to do something different from his normal behavior. Okay, now if you have signatures for attacks, is it good? Is it efficient to detect masqueraders?
Well, if you can change the way that he...
Both of them will detect the two types of intruders. Okay, but I think the first one is more appropriate for masqueraders, or the first one where you have attack signatures.
Yeah, mostly masqueraders. It's not.
It's not necessarily. Maybe a masquerader knows how to deviate the signature.
Again, both of them will work in both situations, but which one is more convenient?
The second one is more convenient for the insiders, because you're always
So you will detect insiders better.
activity. You're always seeing their preference.
So yeah, because if you have a signatures for attacks, basically if everything is going fine, everything is using the system normally, you will not raise anything, and you will raise a flag or an alert as soon as there is an attack model in the network, right? So yeah, the first type is more appropriate to detect masqueraders. Yeah, but it will detect also insiders. This one will detect insiders, but not as good as
But if someone doesn't follow the model that you have in his attack, the second one will detect him, but the first one will not detect him.
Will not, yes. So basically here in the second way, if you have a model of normal behavior, this is normal behavior, this is appropriate for insiders. Okay. Now, if one insider deviates from his normal behavior, this one will detect, and more appropriately. But again, both of them will work in both situations. Okay.
Could you explain the first one again?
The first one here, the intrusion detection system, will keep signatures of attacks, signatures of abnormal behavior in the network. Okay. This second one, it will keep signatures of normal behavior. Okay. So you have your descriptions of how this can be done. For example, when there was audit. When we say you observe the network, you can do it in two scenarios. When you observe the network, you can do it live, while the network communication is going on and back and forth, etc. Or you can do it offline. How you can do it offline? So you analyze the log. So basically, audit records. You have audit, which are the list of logs, okay? And then after at the end of the day, to see if something wrong happened during the day, you will go to all that log and try to match those signatures and find abnormal behavior. Because this is detection. Detection, you can do it even a little bit later. Okay. So auditors.
How much time before it gets very large? The audit would be very large after a while.
It depends on the size of the organization. Depends on several things. But the point here is that the intrusion detection system will work on the log. Okay, so offline. Okay.
Yes. Where are the logs saved?
Depends. So if it is in your host, where logs are saved? There are some folders just for that. Okay. If you have a network and you need to keep the logs of network communications, most of the time you have a server just for that, a log server. Okay, and you know log management is big task. There are any IT employees specialized in log management, how to store it, how to when to remove it, how to analyze it, all that. Okay, so it depends on the size. Okay. Yeah, these all are techniques of detection. For example, this threshold detection. So you have the network packets, you have details about the network packets. So you here when we say threshold, you will compute some numbers. Okay, if certain numbers exceed a certain level, you will throw, for example, count occurrence of specific event over time. If you see, for example, there are more normally in a typical day, you will have 20 attempts of login. Okay, if you see there are 100, okay, attempts of login in a certain day, this you exceeded the threshold. Let's say 50. Okay, if you exceed the threshold, something is wrong. So it is based on threshold. If exceeds reasonable value assumed intrusion alone, it's not by itself. It's not enough, but it can be used. Profile based, you have a profile for every type of a user, okay, and you represent them in the way you want. This is also audit record analysis. This is the second type where we have a model for normal behavior, rule-based intrusion detection system. And I think this is the last one before. This is the precision, and again, this is a trade-off. Okay, so practically, an intrusion detection system needs to detect a substantial percentage of intrusion with a few false alarms. So here, the precision. So basically, when you detect something, how accurate it is. If you detect, you have an alert. Okay, there is an attack here. Now, that alert might be true, might be wrong. Might be normal behavior, and the system detected it in the wrong way. Okay, so there is a trade-off. If too few intrusions detected, if you see that intrusion detection system is detecting very few, while you suspect that there are more attacks going on, what does it mean? This?
Weak security.
So basically, there are a lot of events not detected. Okay, but here the precision will be slow. It will be low or high.
No.
No.
Hi.
The precision will be high. What does it mean, precision here? It means when the system tells you there is an attack, it is really an attack. So in this case, most probably, the precision is very high. Okay? Basically, what's happening here? The system will not alert or trigger the event only if it is 100% sure. Okay? So if it is like 80% sure, it will not raise a flag. Okay. So the precision here is very high, but there is a false security because why? Why there is false security?
Because he let the 80%.
Yeah, because basically a lot of others intrusions are not reported. Okay. If too many false alarms, if too many intrusions detected, a lot of intrusions are detected. What does it mean?
No position.
The precision will be low. Precision will be low. Okay? But is there an attack that will not be detected, basically?
No, most likely not.
Most likely not. Most probably not. Because the system is, whenever it suspects anything, okay, this is an attack, this is an attack. But there will be a lot of false positives. Okay? An attack reported while it is a normal behavior. Okay? So this is basically called the precision, this is called the recall, which is the coverage. How much of true intrusions the system is able to detect. Okay, this is called the recall rate. Okay, so the goal of a good intrusion detection system is to have a good trade-off. Okay, so precision should be high, and also the coverage or the recall also should be high. Okay, this is very hard to do. Yeah, it's very hard to have this trade-off. Existing systems seem not to have a good. Oh, okay. So this distributed, last one. So basically, if you have distributed intrusion detection system, basically you have several entities in the network watching out and trying to detect stuff, okay, in the network. And the point here, those entities needs to exchange some reports, some records, some logs, etc. Okay, and the list focuses on the system, but we have. So this is why we need to deal with varying audit record formats. All the devices should use the same format to represent the events. Okay, and also there are problem of confidentiality because the log data is exchanged between all the hosts, and you need to do it in a secure way. Okay? It can be centralized or decentralized. Anyway, let's stop here. Next time we're gonna see the network intrusion and host intrusion.